this. You're at home, yes, and you create another one for the NMOS, and you start. Where is it? And you start connecting the inverter. I have here created it before, so you can see here I am using, when you hit this, I'm using this PMOS and this NMOS and the connection between them of type metal 1. And here is a few, let me show it more. Here we have an input for the inverter and the output, the ground, and the VDD. After connecting the inverter or wiring them, BMOS and NMOS to create the inverter, we'll just hit DRC check to see if there is any violations. So it says here 0 errors. So we are done with the inverter. And in every step you are creating the design, you can simulate using T-Spice. You can simulate your design to check its correctness. I will show the T-Spice later on in this video. So let me close this one. From this inverter, as you can see here in the circuit, we have to use two of them and the NAND. So I created before this NAND gate using 0.18 technology. So I utilized, because I am doing a full custom, I didn't do it using the NMOS and the BMOS that I created before, but instead of that I just tried to utilize the area and these. So instead of taking two BMOS and two NMOS, I just created the NAND gate in a full design manner, full custom design manner. So let's check it. So it says 0 errors, that's mean no errors. And now I have the NAND and I have the inverter design already. So in order to finish this circuit, I will use another cell and I will instance the NAND and the inverter twice, because here I am assuming that the inverters are of the same size. So I just instance this inverter twice in the new cell and do this wiring. I created here already. I created and I call the cell ring oscillator, I think. Let's check it. Yes. So here is the first inverter, the second inverter, and the NAND gate. And we make the VDD and the ground more bigger, just because now this represent like my core. So it should be the VDD and the ground and the output should look bigger in order to distinguish them when I am calling this core into with the frame, the bad frame, I mean. So let's check the final design of the ring oscillator. So it says here 0 errors. If there is any error, you just click here to show where is the error and just correct anything. By the way, if there is an error here, for example, you made any changes, for example, in the inverter circuit or inverter cell, it will be reflected in any other cell that is using this inverter. So for example here, if we just remove this connection between the PMOS and the NMOS, it will be reflected here in the ring oscillator design. So this will make it easy for us to correct any errors even when we finish with the whole design. Uh, Now I have this ring oscillator. In order to show the correctness of this ring oscillator and it is oscillating, you have to, after you check the DRC is okay, no errors, you will have to export this ring oscillator to a spice file. So from here tools, uh, you can, let me open it again. From tools you can go to extract setup, and here it choose where is your extraction file. This is usually is coming from with the technology file. So we are here using the 0.18 micron technology.ext, which is extraction file, and here you specify the name. Let me call it ring oscillator 2, the name of the generated or the extracted output file, and you browse its location. Default is the directory of the project, is the directory. So you can hit OK, and from tool itself just click extract. It says extract command file. Yeah, so I have here problems. I need to check this technology again. So I'll go and change this to the original folder that I have technology file. Here is the extraction file. Just click OK, and then you hit extract. There is an attached board, says the ground, and you can hit home to check. Yes,